I am so excited for this interview and presentation. This is Dr. Sotiris Nicolopoulos. Took me a while to learn how to say your name right. And welcome to our NUMI week. We're so excited that you could join us this week.
It's a pleasure, always a pleasure to talk with new me,
Oh, thank you.
especially with you.
Oh, ditto, ditto times 10. I had the joy of being, Shannon and I actually had the joy of being with Dr. Nicolopoulos and his family when we were in Greece. And we had a lot of time, he and I had a lot of time together, and we had time with our families. And it was on a 1 to 10, it was about 1,000. And so we just love it. Shannon fell in love with, uh, she really fell in love with your wife, needless to say. And who wouldn't, right? And
Yeah,
his
same.
daughters are just amazing. So, well, uh, he's prepared a slide presentation, and we'll go through that now. And then after the presentation, I will ask questions. I don't have them written down because I haven't formed him yet, but as he goes, I'm sure I'll write them down and we'll go from there. Okay?
So this is a slide that shows how life goes on inside our cells. We are an organism that is made of around 31 trillion cells, and each one of them has this order of molecules inside it. There's the DNA that we inherited from our parents. The DNA, actually, parts of the DNA make the so-called active genes, okay, which they're going to give you your mRNA, and the mRNA is going to give you the proteins. So this dogma was around since biology was started, but in the very recent years, the scientists found that there's a big issue of the so-called epigenetics, which is what the red letters that you see on the top next to the DNA shown. It's the histones modification, the DNA methylation, and some molecules like the microRNAs and long non-copying RNAs that they don't encode for anything. But all these things actually control how life goes on and how active your genes are and how differences among individuals are exist. Can we go to the next slide, please? So this is a slide that shows what epigenetics is and what we so-called epigenetics factors, all these epigenetic factors, control our cells and how life goes on. So the DNA is in the center. So this is what we inherited from our parents. But the epigenetics, which is very important around the DNA, all these chemical modifications and these small molecules that I mentioned before, is what make changes and make things different from each individual to individual. So around in this circle, you see all these so-called epigenetic factors. You see nutrition, drugs, disease exposure, environmental correlations, microbiome, smoking, even the psychological status or the way of thinking, your personality is very important epigenetic factors that control how our genes work. This is a slide that we show here. We used it when we try to see the differences in how NUMI products work in terms of gene expression, how the genes, as I said before, working. So this is a quantitative real-time PCR methodology that is a very accurate and very sensitive methodology, but which we basically quantitate the exact numbers of RNAs inside our cells. Yeah, let's talk about oxidative stress. This is a slide which I like it. It represents with a very, very nice way what's happening inside our cells when there's too much of oxidative stress. So on the top, you see a tomato that when it starts ripening, it ends up to be garbage and we throw it out. But on a cell, when it's attacked by so many free radicals, when there's so much oxidative stress, there are many damages that occur inside the cell, and the cell try basically to defend, but it ends up with so many damages that, and they're gonna end up to some pathology for sure.
And you've tested a lot of supplements. Have you
Yes.
seen this in any other supplement?
No, I haven't seen these dramatic effects. We've seen some reduction. Yes, we've seen, but never. I never looked so early. 14 days and 1 month, never.
Yeah.
Usually, we look after 3 months after taking a supplement. What's going on?
Now tell us for a minute, let's do a little rewind and tell me about how you came to find out about Numi.
I was introduced to Numi by my friend Rose. You met her.
Uh-huh.
She's a university professor, used to be microbiology. So she came to me and she told me, there's something that it's very, very, very interesting. I said, what is it? She told me about the technology. I didn't know anything about the hydrostat technology by that time, which was late November, early December 2024, okay, a few months ago. So I looked into it with, to be honest with you, with some, hesitation, I would say. I said, can be that true? Can be, I mean, how can they manage to do that? Because I read about the technology, this is a passive diffusion inside the cells, by, overcoming the, all these small size of the cell membrane, but cannot
Mhm.
anything to pass by beside beyond, the cell membrane. So the next step was to try for myself. So I made an order. I used the product, and the very first thing I remember was the day after I used the product. I went for a walk.
Mhm.
So I used to walk 10,000 steps every day. So after using this product and walking 10,000 steps, I found out that I was not tired at all. I was ready to go for another 10,000 steps. When, usually after 10,000 steps, you're tired, you want to go and rest. I said, this is something big here. It can be, it's not a coincidence, it's not placebo, it's nothing. And then, the story started, I wanted by myself to look what's going on with inflammation and all that. And this is how it went.
Now, you prior to this, you had been on a liposomal glutathione.
Yes,
Had you seen anything like this in your own experience?
no, no, we haven't seen this. I don't think glutathione, liposomal glutathione works. My my impression.
Now, tell us the difference between a liposomal encapsulated molecule and one that's with hydrostat.
Well, the encapsulated glutathione in liposomes uh, is a big structure, first of all, because the liposome contains a lipid bilayer, like our cells, the cell membrane, artificial, of course, lipid bilayer, and inside there they have encapsulated the molecule. So the way it goes is it's always in liquid form. It's gonna start when you take it, start fusing. The membrane of the liposome fuses with the membranes of our epithelial cells, and after this fusion, it releases the inside, which is the glutathione molecule inside the cell, supposedly. Of course, this is a process that requires energy, and it's not as not as perfect, as efficient, I would say, as theoretically is. Theoretically, it is, but practically, it's not as efficient as we think it is. The hydrostat technology, on the other side, for me, it's genius because it makes a structure which is basically some molecules of water, and it brings the molecule inside the membrane, okay, by passive diffusion. I mean, if you would say that before some years, they would say that this is impossible. It cannot be done because the
So,
the cell has its own uh, restrictions, very, very strong restrictions. It cannot allow to enter anything, basically. It has to be like a virus, so small. You see the virus, how easy infect us, because of its size. The size is unbelievably low.
yes. Okay. Well, thank you very much for the interview. And we're excited. Dr. Nicolopoulos joined our um, uh, medical and scientific board, and he has been a delight to work with and has really impressed some of the other doctors on our medical board. In fact, one doctor from the Cleveland Clinic joined our medical board as a result of spending a little time with Dr. Nicolopoulos and myself. We were on a Zoom together, and uh, Gareth Morris Stiff, who is a liver specialist, when he saw what we had and what Dr. Nicolopoulos was able to measure through real-time PCR, he just threw up his arms and said, "I'm in." And so it's just exciting. We have seen wonderful results with our technology, and people always say, "Show us the science." Well, now we have the science. We see what we're doing. Now, the truth is, there's 194,000 published studies on glutathione, and quite a few of those show that glutathione, when it is efficiently and effectively delivered into the cell, will impact inflammation, will impact genetic expression, and so on. The problem has always been delivery, that not everything that you put in your mouth ends up in your cells, that the cell particles the cellular size is so small, and within the cell there is a even tinier pore, and and many products are use force diffusion. In other words, they sit on top of the cell versus actually getting in through the pore. The particle size with water encapsulation, the way we encapsulate with hydrostat, the particle size is so tiny that it's able to actually get in the cell much more easily through a passive diffusion, which is what you're talking about. And now we see how it works and why it works. So thank you so much for all you do. I know over there, let's see, it's almost 7 o'clock. Thank you for giving us your evening. And God bless you and your sweet family, and we'll talk to you soon.
Thank you so much. Thank you. It's always a pleasure, and you know, I'm very glad just to talk with you and basically investigate further what's going on.
Yes, you
We're gonna
said
have more. We're gonna have more data, more things in the near future. I'm not gonna say anything yet, just gonna keep you alert.
But you're seeing good things.
Yes, absolutely.
Okay, I can't wait to get the data. And for you
Okay,
and me, nothing speaks louder than data. So
exactly.
thank you so much, my dear brother.
Very welcome.
God bless you and your family.
Thank you. The same to you.
Oh, thank you, Sotiris. Bye-bye.
Bye bye.